Welcome. Today we're going to learn how to get started with Kubernetes using Rancher. See, I jumped ahead one. Let's introduce ourselves first. I'm Rachel Coonley, the Technical Marketing Manager here at Rancher Labs. And here with me today is Rajashree, one of our software engineers. And we're also joined by Hussein and Mohammed, two other software engineers here to answer your questions at the end of the session. You can reach us on Twitter. Today's objectives, the purpose of today's training session is to provide a technical introduction to Kubernetes using Rancher. And I promise to keep the slides to a minimum and focus on demoing. I'm going to demo how to get Kubernetes up and running in Rancher, and then I'll be handing it over to Rajashree, who will explain some Kubernetes concepts and how they work in Rancher. Questions are always welcome, and we won't leave until we answer all your questions for you. So first, some assumptions. For the purposes of this training session, we assume you have an understanding of basic Docker concepts. There are many parts of Rancher that we won't be covering today, but we do offer a monthly training session, Introduction to Rancher, and the next one is on Thursday, November 9th. You can register using the URL on the slide. It's rancher.com/training. We have a couple of great resources available to you online. First, we have a pretty thorough documentation site at docs.rancher.com, and it's only going to get better. I have some changes in the works. The URL on this page goes directly to the Kubernetes section for the latest version of Rancher, so you can get straight to the information you need for today's session. And then we also have forums.rancher.com where you can ask questions and get pretty timely answers because we have a rather active community there. So key topics. Here's what we're going to be demoing today. First, I'm going to talk to you about setting up Rancher, deploying Kubernetes, and setting up kube control. Then Rajashree is going to take over and talk about pods, deployments, services, config maps, and ingresses. So some people ask, why use both Rancher and Kubernetes? Well, they're just better together. If you've ever tried to set up Kubernetes for yourself, you know it can be a bit difficult to get up and running. Rancher provides a nice, easy-to-use interface that lets you manage across different cloud providers using different nodes or hosts. Another cool feature is that we physically automate your upgrade process. So when there's a new release of Rancher and then there's an updated version of Kubernetes, after you upgrade Rancher, you can just upgrade to the latest version of Kubernetes with one click. And we have infrastructure management across clusters and clouds, automated deployment of the latest Kubernetes release, upgrade management and rollbacks, and 24/7 enterprise-grade support. So now it's time for me to do a demo. We'll get to the good part. Stop the slides for a sec. Oop. Give me one sec. Okay, so for the purposes of this demo, I had to get some things set up in advance because they take time to get up and running. So earlier today, I started Rancher on the box itself, and normally when you first log in, you'll see a welcome screen. And at that time, we encourage you to leave the telemetry box checked. You'll see there's a little checkbox, and it'll allow us to collect stats. And that way we can ensure that we're testing the most popular distributions and combinations for you. So after that welcome screen, you will be initially in the default environment. And this environment uses our cattle orchestration. And the first thing you're going to want to do is enable access control so no one can mess with our demo. So I'm going to add I'm going to do local auth here. And I'm going to add registry as, oh, not an admin user, sorry. 1 second, I want to set her up as a regular user. You know, I think I have to set myself up as a admin user first here. So give me 1 sec here. Okay, and now I can go back and manage accounts and add an account. And I'm going to add her in here as a user so that when it comes her time to take over the demo, she can log in. So I click create, and there you can see that both of us are now in the environment as admin and user. So there are default environments you can edit, and in this case Kubernetes. So we want to go to click the manage environments. Which is under default. And then we want to add environment. And here you can select Kubernetes. And click create. And then you will see it here under environment templates. One sec here. Bear with me for 1 second here. I'm sorry, I'm new and I seem to have completely lost my place.
So I think we can just continue by adding a host in the K8s test environment.
Thank you so much. I lost my place. I was trying to show the configuration options under Kubernetes, like plane isolation and RBAC.
Oh, okay. So maybe if you click on the edit environment, you'll be able to see that on K8s test.
Is it right here?
Yeah, just on the case test that
Okay, I think the go to webinar control panel was blocking my screen, so I
Oh,
couldn't see it. I'm so sorry.
no, no.
Okay. Okay, so and then I do edit config here.
No, so like if we go back to the K8s test environment, in manage environments,
Under here.
yeah,
Okay.
edit K8s test. And over there, if you scroll down, we can, I think we should be able to, oh, it's not showing the, or maybe we can just like try creating a new environment and show what all options we had selected for this one.
Okay. So would it show up under edit? Okay, there it is. I did need to click Edit Config. I'm sorry. If you click Edit Configuration, I just wanted to show you, and I'm so sorry I had trouble finding them. I'm new to the company and I'm learning this too, so I apologize for the delay there. Okay, if you click Edit Config on your on the Kubernetes environment, I just wanted to talk for a minute about these configuration options now that I've finally found them. The first one I wanted to mention is plane isolation. And when you're in production and you need to isolate the data, orchestration, and compute planes, you'll need to enable that. And then you can also turn on RBAC here to manage the namespaces within Kubernetes. And then if you are behind a firewall, you can set your private registry here. And then we have by default the Rancher ingress controller enabled. And so if you create an ingress, it'll use your Rancher's load balancer, which is running HA proxy, and to service your containers, or if you want to use something like Nginx ingress controller instead, for example, you want to select false for this option. And then by default, we have Kubernetes add-ons enabled, and that includes the dashboard, Helm, SkyDNS, and more. And we don't really recommend turning off this option, but you can if you want. And then finally, there are some options toward the bottom that relate mostly to etcd and backups. So once you're happy with all the options there, you can click Configure. And then for your template, and then I have already added my Kubernetes environment for the purpose of this training session. But at that point, then you can add, an environment. And then we want to switch to our Kubernetes environment. And you'll see that it's setting up Kubernetes. And while it's doing that, it wants us to add at least one host. So we're going to go to Infrastructure Hosts and then click Add Host. And then we have some different options. If you're using a different cloud provider, you can select that, or you can run a custom command on any host that you've already spun up. So I've already got some ready for the purpose of this demo. Just to speed things up. So I'm copying the command here to register the host. And then we see the host pop up. And then we can see, you know, it all spinning up here. It just takes a minute. And for Kubernetes, there are health check, IPSec, the Kubernetes stack should show that it's up and running in green. And then we have an option for the Kubernetes CLI, kube control, and dashboard as well. And those will show up under the Kubernetes tab once you have that host ready. And you can click Kubernetes and see that you can get to the Kubernetes dashboard here, or the CLI to use kube control commands right here. And you'll notice that when I hovered here before, that wasn't there before we added that host. So now I'm going to hand it over to Rajashree, and she's going to talk about more Kubernetes concepts and continue demoing them in Rancher.
Hey everyone, can you see my screen? Okay, I'm just going to take that as a yes. And so let's go ahead and start with some Kubernetes concepts. Yeah, so I have logged into the setup that Rachel just created. Okay, Rachel, actually, can you give me access to the K8s test environment that you created?
Do you need the URL or?
No, I just need, so if you go to manage environments and edit the K8s test environment and add me as a member in that, I'll be able to access it.
Okay. One sec. Oh, I'm sorry about that.
No, that's fine. So we'll be covering a few of the key concepts in Kubernetes. These are the basically, like, just a second, sorry.
Sorry, just a second.
Yeah, sure. So these are the resources that are like available within Kubernetes, and these concepts are basically purely Kubernetes concepts. So they won't change based on how you are deploying the cluster. It's nothing Rancher specific. So the first concept that we are going to take a look at is pod. Now, a pod is the smallest deployable unit in Kubernetes, and it runs one or more containers within it. Kubernetes supports more container runtimes, but Docker is the most commonly known container runtime. And like all these containers that are run within a pod are tightly coupled, meaning they get scheduled on the same host. Now, each pod gets a unique IP address, and this IP address can be used by other pods and deployments within the cluster to access it. Now, as I was saying that these containers are tightly coupled, so they also have shared storage volumes and network namespace, which means that these containers share the same share the IP address of the pod and also the port space. And that's why they can find each other, communicate with each other via localhost. So since the pods can contain more than one container, this concept can get a little confusing, but we don't need to worry about that because most of the mostly known Kubernetes use cases typically have only one container per pod model. So we are just going to use pods that run a single container per pod for the purpose of this training session. And yeah, so now I have access to the Kubernetes cluster that Rachel had set up. Now, in order to use this outside of this shell, I mean, from anywhere, I just need to generate this config and copy it and paste it in my kube config. So I'm going to do that. I might have an already existing one, so I'm just going to remove that and create a new one. So now I should be able to access this Kubernetes cluster from here. Okay, so right now there are no resources created. That's why it says that no resources are found. And let's go ahead and create a few pods. Now to create a pod, we can use something called as a manifest. So manifests are basically YAML files that let us define the resources that we, that let us define the resources that we want to create. So let's take a look at creating a simple pod using this file. Now, most of the fields in this manifest are common to any resource that you will create within Kubernetes. For example, you will have to provide the API version. Then the kind field specifies what type of resource we are creating. And right now we are creating a pod. Then in the metadata, you can provide details such as what you want to name the resource. And you can also provide information like what namespace you want the resource to get deployed in. And you can assign labels and other such things. Now the spec field, under that, we can provide the exact description of how we want the pod to look like. In our case, we are creating a container with the name shell, and we are using this image. Now, this container is not doing much. It's we just want something to let us exec into the pod and do some curl requests for the future part of the demo. So let's just go ahead and create this pod. So it says that the pod has been created. Let's see. So currently it's in the creating stage. And once it is created, we should be able to see it on our host. And as you can see on our host, we can see this shell pod running. And it is running. Now let's go ahead and create another pod. This time we'll create an Nginx pod. So as I said, most of the fields remain the same. Now we just want to name it Nginx, and we are using the Docker Hub Nginx image. And the other port is 80 that we're using. So we are going to create this pod too. And yes, as you can see, immediately the pod was added to the host. Now both the pods are running. Now, like I said earlier, that each pod gets assigned a unique IP address and it can be accessed by other pods. Let's see how that happens. So for that, I first want to get to know what the IP address of the Nginx pod is. And for that, I can use a command kubectl describe. Oops, sorry. Yeah, so kubectl describe basically gives a detailed description after the pod has been started, what all has been assigned to it, and say things like what IP address has been assigned to it. So we are going to use this IP address and see if it can be accessed from within the shell pod that we had created before the Nginx pod. So to see that, I'm just going to exec into the shell pod. This kubectl exec command is like just similar to the Docker exec command. Right. So I'm in the shell pod now, and let me see if I can do a curl on the Nginx pod. And I can, because it's presenting me with the Nginx homepage. So it means that the pods can access each other. Now, the two pods that we created had some were simple pods, but we can provide a lot more fields while creating the pod under the spec description. For example, if you want to expose some environment variables to the pod, or if you want to do volume mounts, that we can also do that via these YAML files. So now let's move on to the concept of deployment. So the pods that we discussed right now, they are basically an ephemeral entity. So when a pod is deployed, it gets found to a node. And for some reason, if that node or if that host goes down, or even if the pod gets deleted, then Kubernetes won't know that it has to reschedule it again on another host, so it won't. And we don't want that. So in order to manage the life cycle of a pod, we use something called as a deployment. So deployment is a Kubernetes concept, like it uses the concept of desired state versus current state. In a deployment, you can always specify the exact description of the pod, how you want the pod to look like, and the scale, the number of pods you want, and so on. And the deployment will always manage to keep the current state of the pod same as the desired state. And yeah, so that's why you will never run the pods directly on the deployment. Sorry, you will never run a pod directly on the cluster. You will always use a deployment to run it. Now, let's go ahead and create some deployments. So for this, again, we are going to use a manifest. Within that, we have some of the common fields like API version. Over here, kind will be deployment. And okay, and over here in the spec, we are specifying that replicas is 3, which basically means we'll get like 3 replicated pods, each pod running 1 container using this Nginx image. Also notice the labels field, which is app Nginx. So this means that any pod that is being managed by the deployment will be assigned this label, app Nginx, to it. We'll see how that can be used later on. So before we create a deployment, let's just quickly look at how many pods we have currently in our system. And now we are going to go ahead and create it. So it is creating the deployment Nginx. And as you can see on the left, it immediately started 3 pods that we had specified within the deployment. So if I do kubectl get pods again, we can see that the deployment started these pods over here, which can be listed by the get command. So now, as you can see, there are 3 pods for this deployment, which means the scale of the deployment is 3. And you can also change the scale of a deployment. For that, you can use the kubectl scale command. So let's say I want to scale it down. I've scaled it down to 2. So now when I do kubectl get pods, I can see that one of the pods is in the terminating state. And eventually I should only be left with 2 pods because that's what I specified the number of replicas should be. Now we are going to take a look at another Kubernetes command called that is kubectl edit. So edit basically presents us with the current representation of a resource within the Kubernetes cluster. So as you can see over here, a lot of the fields are what we had provided in the manifest, and the other fields are what it is, like what the current state of it is. So the current number of replicas is 2. Now say I want to change it back to 3, what it was earlier. So I can do that over here. And then I can see it take effect when I do kubectl get pods again. It again started another pod. So now we are back to scale 3. So this is how the kubectl edit command can be used. Now we can also, there's another command which gives us the detailed description of the resource, and that is kubectl. Oops. We'll do the get with a -o flag, and it will present us the description in the YAML format. So right now we just have one deployment running. Now we can just start another deployment with the kubectl run command. So this is how we use it. Let's call this nginx2. So it has created another deployment, and we can see it over here by doing the kubectl get deployment command. So this covers pods and deployments. Now let's move on to the concept of a service. So we have seen that how pods get assigned a unique IP address, and this IP address can be used by other pods and deployments within the cluster to access it. But again, pods are ephemeral, so their IP address can change. Even if the pod is being managed by deployment, if it goes down, the deployment will start another pod, but it will have a different IP address. So the other pods and deployments need a better way of keeping track of the pods that they need to communicate with. And that's where the concept of services comes into picture. So service provides a DNS entry that can be used to refer to other pods in the cluster. And it is similar in functionality to a load balancer. And it gives a consistent endpoint to refer to a group of pods. So let's just see how that works. Again, to create a service, we are going to use a manifest. Now, these are the fields in it. It's the kind of service, then its name will be nginx. Now, over here, if you see this, there is a field selector under spec, and it contains this label app nginx. So what this means is, any pod that has the label app nginx on it, the service will route incoming traffic to it. So if you remember, when we were creating the nginx deployment, we had provided this label to the pods. So that means like any traffic coming to the service will be routed to the pods that are being managed by the deployment because of this selector. Other than that, we are adding some routing rules to route from port 8080 to 80 and also from port 80 to 80. So let's go ahead and create this service. Let's see if the service has been created. Yep, we can see the nginx service has been created. So now we should be able to access this cluster IP from within other pods. So let's exec into the shell pod that we had created at the very first. Now if I do a curl, and yes, as you can see, I can get the nginx page, which means the traffic got routed to one of the pods that had that label from the deployment. And since we have created a service, which means we have a DNS entry, we should be able to curl to that as well. So for that, the format is curl, then the service name dot the namespace in which the service is, then svc cluster local. That's just the Kubernetes format. And as you can see, we can successfully access it. So the traffic is getting routed properly. We don't know exactly to which pod from the deployment, and we don't need to know that. And we are also specified a rule from port 8080 to 80. So you can see that is also working fine. Okay. So now we are going to go to the concept of a config map. Config map basically lets us create files within Kubernetes and expose them, inject them to within pods. Now, some applications need certain configuration files at runtime, but we don't want these configurations to be baked into the container image, because every time the configuration changes, we'll have to create a new image and then redeploy the pod. Config map avoids all of this. So, for example, let's take a look at the Docker Hub image of Nginx. Yeah, over here, like under the complex configuration section, we can see that while creating the container, we can like bind mount the Nginx configuration. So this would work perfectly fine for a container, because we know where exactly within the host is this configuration file located. But this can't work for a pod running in a cluster, because first of all, we don't know which node that pod is going to get scheduled on. And we can't guarantee that this will be the same path on which the configuration file will be present, or we don't know if the configuration file will be present at all on the host. So that's why we are going to use config maps to provide these configuration files. So let's take a look at the how we can create a config map. Again, it's a YAML file. Now, with this data field of a config map is what actually stores the data that will get exposed into the pods. And it's nothing but it basically creates a map. So essentially, it's a key value, like pairs of keys and values. So this is what we are storing in this config map named testcm, key 1 with value 1 and key 2 with value 2. Okay, so let's go ahead and create the config map. As you can see, it has been created. And it has also stored the data that we had provided. Now, there are two ways of passing this data to a pod that we can create. Now, the first one is via environment variables. So let's see how we can do that. So via environment variables, this is how we do. Like, first of all, we're creating a simple Ubuntu container. And within that, these are the environment variables that we are exposing. So what this block does is, we're creating an environment variable named primary key, which will get its value from the key 1 within the config map testcm that we just created. And similarly, we are going to have another environment variable, secondary key. So let's go ahead and create this pod. So this pod has been created, or rather is in the creating stage. Just takes a couple of minutes, I guess, to seconds to get the image. So now let's exec into the pod. Right. So now if I do env over here to list what all environment variables are there, I should be able to see the environment variables that we had exposed to the pod. And so we can see them. We had added primary key with the value of key 1, that was value 1, and the secondary key is also present here with the value 2. Now, the second way of exposing the key value pairs that we had added to the config map data is via volume mount. So let's see how that is done. So over here, again, we'll create a pod with a simple Ubuntu image. And in that, under volumes, we add the config map data under volumes. So we are providing this testcm config map that we had created. And this volume mount path specifies where within the container will it be mounted. So it will be present under /etc/config as per our manifest. So let's go ahead and create it. The pod has been created. Right, so the pod is running. Now let's exit into the pod. Right, and the path that we had specified was /hc/config. So within that, you can see that the key data that we had added to the config map is added as local storage as files. So let's see the contents of these files. And it is value 1, like the content of file key 1 is value 1. That's what we had added. And content of file key 2 should be value 2. And it is value 2. So that's what we were expecting. Now, some of the restrictions of config maps are that they need to be created before they can be referenced by other pods, and also that they can only be referenced by pods within the same namespace. So now let's go over a more detailed example of the config map concepts that we just covered. Now for this, yeah, so for this example, we'll actually create an Nginx deployment that uses an Nginx configuration file, and we'll expose this file to the deployment via config maps. Now, let's take a look at the Nginx config file. It's a very simple config file. It just proxies to rancher.com. Yeah, and now let's take a look at how we before creating the deployment first, we'll create the config map, which will be using this configuration file default.com. And for that, we'll be using this kubectl create config map command. So since we are using the configuration file, we can pass it to it using the from file flag. And it has created the config map. So let's check it. Right. So the data field contains this. So the key value pair over here will be, first of all, the path of the config file will be the key, and the content of it will be the value of that key. And now we want to manage to pass or expose this within a deployment. So let's take a look at how we can do that. So this is the YAML like manifest for the deployment. We are going to name it proxy deployment, and over here under labels, we can see app::proxy is the label that will get assigned to any pods that are being managed by this deployment. So we are using an Nginx image, and the proxy CM is the config map that we had just created that we'll add under volumes. And it will be available within this mount path /etc nginxconf.d. So basically, this is the default path that Nginx will be using to look for the configuration files. So let's go ahead and create a pod, the deployment. Sorry. Right. So it has 2 pods from the deployment. And now we also create a service for this. Now, this service, in this service, we are specifying selector as app proxy. And you remember that this is the same label that we had given to the proxy deployment. So again, any traffic coming to this service will be routed to pods that are managed by that deployment, or pods that have this label app proxy on them. And the rule that we have added is from port 80 to port 80. So let's go ahead and create this service. So the service has been created. Let's just list it. Right. So now, now what I'm going to do is I'm just going to like go exec into my shell pod that I had previously created and see if I can access this service. So using the cluster IP, I should be able to, and I'm able to. So since we were proxying to rancher.com within the default.com file, this is nothing but the rancher page. And we should also be able to do a proxy with the DNS entry. So as we see cluster.local, and we are able to do it successfully. So it calls rancher.com. Okay, so now we have covered like a few of the concepts, and the next thing that we look at is an ingress. So now we saw that the proxy service was assigned an IP address and it was accessible by other pods within the cluster. But in order to make it available to the outside world, we'll have to use something called as an ingress resource. So ingress basically defines a set of rules to route inbound traffic to a cluster service. In other words, it exposes cluster services to the outside world. Then, yeah, we can have specify routing tools based on factors such as host and path. So let's take a look at that. So this is the manifest that we'll use for egress. Now, as you can see, there are two things that are separated by these three dashes, which basically means we are defining two resources within the same manifest. And in the same way, we can add multiple resources. So let's take a look at the first ingress resource that we are creating. We are naming it proxy, and we are binding to port 9000. And so this spec.backend field is like a service port combination, and ingress traffic gets routed to the endpoints that match this backend. So when we create this ingress named proxy, within Rancher, it will like a load balancer with the spec that we provide here will get created. So we are routing traffic to the proxy backend on port 80. And similarly, we have another ingress resource named Nginx, which binds to port 9001. And yeah, we are routing the traffic to Nginx backend on port 80. So we are going to create these resources. So it says it has been created. Let's take a look. So it just takes some time to get an address assigned to it. So as you can see, it is starting load balancers with whatever spec we had provided. It's taking a little time, but it should be up and running. Okay, so yeah, finally we have the addresses of these. And now let's see whether we are able to access the traffic on these addresses. So just a second. We had the proxy service on binding on port 9000 and Nginx on 9001. So let's check if we can access them. And we do, because we were just proxying to rancher.com on port 9000. And let's check on port 9001 if we can. Yes, so that is working perfectly fine. Like we can get the Nginx homepage on that. And yes, so I guess that's all I had for today, like for covering the basic Kubernetes concepts. Yeah, that's all. So does anyone have any questions?
Joshua, I think all the questions have been addressed in the question
Okay.
panel.
Okay.
I think you had a couple of wrap-up slides.
Oh, yeah, sure. So, like this is our Rancher user Slack URL that you can use, and look, if you have any questions while using Rancher or Kubernetes within Rancher, they can get answered over here. And yeah, I guess that's it since all the questions have been answered. This is all that we had for today's training session. So, thanks. Yeah, that will be it.